Welcome. In this tutorial, I'm going to show you how to model stress due to thermal expansion in a simple bar. So to set this up, the first thing I'm going to do is grab the static structural icon and drag it over to our green box here. And then we're going to update the material. So I'm going to right click on engineering data and click edit and right click and then choose engineering data sources. And again, you'll see here there's libraries of ANSYS materials. So I'm going to click on general materials. And we're going to, for this analysis, I'm going to use stainless steel. So I'm going to left click the plus button. Now for this analysis, I'm going to do a 2D plane strain analysis of the bar. And I'm going to click on geometry and then change the analysis type to 2D. And then we're going to create our geometry. So I'm going to left click on geometry and then right click and then left click new design model or geometry. And we see here that the CAD window for design modeler has opened up. And I'm going to draw the bar in the XY plane. So I'm going to left click on the Z normal vector here. And then if we click on our XY plane, we'll see the global coordinate system and the XY plane show up. Now I'm going to do this in inches. So I'm going to go up here and left click on units and then left click inches. And for this analysis, I'm going to take advantage of symmetry. So I'm only going to model 1/4 of the bar. So to do that, I'm just going to draw a rectangle. And I'm going to click on the origin. And then we'll left click again to place the rectangle. Now I'm going to dimension the rectangle. So I'm going to leave it to general. And I'm just going to model a 1-inch bar. So I'm going to make this dimension of the right end of the rectangle half of our thickness, so it'll be 1/2 inch. And then I'm going to dimension the length of the bar, which is going to drive our thermal stress. Let's say we'll make this 5 inches. And we're all set with the sketch. So now I'm going to come here and I'm going to click on modeling. And then to create the surface body, I'm going to left click on concept and then left click on surfaces from sketches. And then I'll expand the tab for the XY plane and left click on sketch and then click apply and then click generate. The next thing I'm going to do is I'm going to come back to the main menu and I'm going to save the analysis. And then I'm going to left click on model and then right click edit. And we'll see the 2D representation of the bars shown up here. And what I like to do first is just look at the global coordinate system and make sure that it's aligned with where we want it to be. Now I'm going to set up the geometry. I'm going to change our 2D behavior by left clicking on geometry. And then I'm going to do a generalized plane strain case. And now the fiber length is going to be the thickness in the Z direction. So I want that to be 1 inch. And then I'll left click surface body and I'm going to change the material to stainless steel. So I'm going to click on material assignment and then left click the arrow and left click stainless steel. And the next thing I'm going to do is mesh the model. So I'm going to left click on mesh and I'm going to change the element order to quadratic. And then on right click insert sizing. And I'm going to click on the face icon here and then left click the surface body and then left click the yellow box and then left click apply again. And I'm going to change the element size to 1/8 of an inch, so 0.125 inches. And then I'm going to right click and then left click generate mesh. Now the next thing I'm going to do is set up the boundary conditions. So I'm going to left click on static structural and then right click insert. And I'm going to set up our symmetry conditions. Now you can do this with the displacement by actually constraining the normal displacement on the symmetry boundaries to 0. So I'm going to left click this left rectangular edge and then left click apply. And I'm going to set the X component to 0. And then we're going to add another symmetry on the bottom. So I'm going to right click and then insert displacement and click the bottom edge, click apply, and then set the Y component to 0. Now the next thing I'm going to do is set the constraint on the right edge. So we'd like to constrain the bar so that it only constrains it in compression. So I'm going to right click, insert, and then click on compression only support. And then I'll click the edge icon and the right edge of the rectangle and then left click apply. Now we're going to set up our temperature boundary conditions. So I'm going to click on static structural and then right click and then insert. And I'm going to left click thermal condition and left click on the body and click apply. And now to get the delta T, we're going to run this analysis at 2 load cases. So I'm going to left click on analysis settings and then change the number of steps to 2. And you'll see here when you do that, you will get a table on your displacement boundary conditions. That's a function of your time and your step. And so you can see that the displacement on the left edge is 0 for both steps, and the displacement is 0 on the y direction on the bottom edge for both steps. And then our thermal condition, to simplify the math, I'm going to change 0 to 70 and then 1 to 70. And then our step 2, we're going to add our final temperature. Let's say 120. So we'll have a 50-degree temperature delta. And then now we're going to set up our post-process stress. So I'm going to left click on solution, then right click insert. We'll look at the normal stress in the X direction. And then we'll say we'll look at the equivalent and principal stress, max principal stress. Okay, so we are all set to run the analysis. So I'm going to left click on solution and then right click and left click solve. Okay, so the analysis is completed and we can look at our stress. And here we have our stress is uniform in the bar, which is what we would expect in the x direction. And if we want to look at the first time step, you can click on this one here and then right click retrieve result, and it should be 0. And yeah, it's e to the negative 11, basically 0. And then if we want to go back to our final stress here, click on 2 and then retrieve result. And so in the next video, we'll compare the results of this analysis to our hand calcs. But you see, since the stress is uniform everywhere, the equivalent stress, the normal stress in the x direction, and uh, the max principal stress here is going to be 0 because our stress is compressive. So I need to actually insert the minimum principal stress. And if we retrieve that result, we'll see that our minimum principal stress is equal to our normal stress and our equivalent stress, which makes sense. But we'll go over these results in the next video. We'll compare them to our simple hand calc. Yeah, thanks for watching, guys. Hope you stick around for the next video, and looking forward to making more videos. Thanks.